Okay, welcome to this tutorial on Newton's method or Newton-Raphson's method. Okay, basically we are going over a fixed position method rather than an interval method. Okay, so let's get into it. So Newton's method. Okay, so the equation is as follows for Newton's method. It goes as follows. So x of I plus 1 is equal to xi minus f of xi over f of f dash of xi. Okay, so the next iteration, xi plus 1 is the next iteration, is equal to the previous value minus the function, the value of the function, minus the value of the derivative at that position. Okay, so Newton developed this while trying to solve this function, and so we should try to solve it as well. So he developed this method when trying to solve for the roots of x cubed minus 2x minus 5 is equal to 0. Okay, so we usually have to, or we are usually given the starting position, or where we want to, where we think the root kind of lies, and so for this we're given that x naught, or starting x position, is equal to 1. Okay, so because we have calculators, the easiest way to do this is by using the answer function on your calculator. So what happens is, on these Casio calculators, you can store your answer. So what you do is you click 1, because our starting point is 1, click 1 equals, okay, and then you use the answer function in this method, in Newton's method. Okay, so what you do is you type this into your calculator. So x is going to equal answer minus, okay, our function is answer cubed minus 2 times the answer minus 5 all over the derivative of this. Let's just write that here. F dash of x is simply going to be 3x squared minus 2. So we have 3 times the answer squared minus 2. Okay, and then what you do is, once you have it in this format, you go ahead and you go crazy on this answer button, and you keep clicking equals, okay, until you see that the value starts to actually plateau or become constant. Okay, and if we keep clicking answer, we come out with the answer x is equal to 2,094551482. Okay, so when you type into your calculator, whatever you type should look something like this. Okay, so you should be storing the answer, and all you need to do is then click equals 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 until you see that the number starts to converge to a given number. Okay, so Newton's method is quite easy. Okay, but there are some things that we need to be mindful of. Okay, firstly, Newton's method, obviously, we need to be able to give f dash of x. So must know the derivative. If we don't know the derivative, then we can't use this method. Okay. Also, what we end up having is a bit of a problem with functions that are sinusoidal or periodic. For example, a sine graph looks something like that. So there's intersections here, here, here. Okay, Newton's method can only pick up one of these intersections. So in this case, let's say we had a sine graph, and we had our starting position x is equal to pi over 2. So pi over 2 is right here. Okay, so if we follow Newton's method, we end up converging to this solution right here. But this will be the only solution we get. We will not get the solution here, or the ones that continue. So basically we're restricted and we're limited. Actually, in this case, we might even converge to that solution right there, depending on our calculator's mood. So we have to be careful, and we have to be mindful of this. So it can get stuck in things that we call sinks and basins, and it may not converge at all. So if a function doesn't actually ever reach the axes, we might not know this, and we keep clicking equals, and we will never get to a value. So those are some things to be mindful of using Newton's method. Okay, so This was a relatively short video, but I don't want to go into the next section. But the next section is going to be using Newton's method to solve for systems of nonlinear equations. Okay, so that's a bit more complicated, but yeah, I hope this was useful. It was nice and quick and short, but Newton's method is that. It's easy, and I hope you guys found this useful. Thanks.